much of this diversity, both in terms of species number and ecological diversity, is concentrated in the freshwater ecosystems of the neotropics, Africa, and Asia. Cichlidae is amongst the most ubiquitous family of fishes within these tropical ecosystems, and the rapid diversification and diversity of the African rift lake cichlids have already established them as a model system for studying adaptive evolution. However, recent increasing interest in the patterns that have occurred in riverine cichlids, particularly in the neotropics, has shown that they also exhibit very high species richness and ecological diversity and interesting patterns of diversification, suggesting that they are perhaps a complementary system for studying adaptive evolution patterns in riverine tropical ecosystems. However, to study adaptive evolution, you need a phylogeny. So where are we with the cichlid phylogeny? A lot of efforts have been very justifiably put into resolving family-level relationships. And what this has shown us so far is that the neotropical and African cichlids are reciprocally monophyletic and that they diversified following the divergence of the Madagascar and Asian clades. At the subfamily level, a lot of efforts have been put into resolving the neotropical cichlid relationships. And in Africa, a significant amount of effort has been put into resolving the rift lake cichlid relationships. Fewer phylogenetic efforts have focused in the non-rift lake cichlid relationships, and when they have been included, it has tended to be more as token taxa included to resolve family-level relationships or relationships with the neotropical cichlids or the rift lake cichlids, or to look at specific within genera relationships. So as a result, we kind of lack a bit of understanding about deeper relationships in a lot of the African cichlid clade, particularly with respect to the riverine cichlids and the smaller lake cichlids. So I'm not going to go into any amount of detail on my method for lack of time, but I'm happy to talk about it at some point during the conference, or I've also got my contact info here in the next slide. But essentially what we did is we took 923 single copy exon probes, and we used next generation sequencing to capture successfully 588 exons for 188 taxa. So that amounts to 171 cichlid species and 17 outgroups, and those 171 cichlid species include almost all of the genera of riverine cichlids and small lake cichlids, including those from crater lakes and other small lakes. Before I go into the tree building approach that we took, I just wanted to make a very brief note, just so you know this is happening, about a bit of an issue that we ran into and how we resolved it. So when we were trying to assemble our reeds, we used the tilapia as the reference for guided assembly, and that worked great for the mainland African taxa. However, the Madagascan taxa, we got very poor recovery of our exons, very patchy exons, and of course that's no good for a phylogenetic inference. So what I did is I took a sort of hybrid guided and de novo assembly approach. So I assembled these reeds de novo and also with the tilapia as a reference, and then lined those together and got the consensus sequence out of that. And in most cases, on average, we saw 11 to 20% increase in the amount of the exon that we recovered. And as you can see from these little points at the top, in some cases even more than that. So that's really good, lots more information for phylogenetic analyses. And that means that the information was there, it's just perhaps the Madagascar cichlids are just too divergent for the tilapia of reference to work for assembly. So we aligned those sequences and we took two tree building approaches, traditional concatenation methods and also a species tree approach. Today I'm only going to talk about the concatenation approach because we're still waiting on the results for the species trees. And I just want to point out some of the major patterns that we see. So I've kind of divided up Africa into West Central Africa and East Africa, as it tends to be done looking at the river basins. So West Africa versus that big chunk of land that kind of sticks out, and Central Africa is kind of this middle part here. And East Africa includes the rift lakes. So this part right here, hold that there. That's the African mainland radiation that we see, and you can see the lineages that diversified basally are mostly West and Central African, and largely from the Congo Basin. Following that, we have a very large divergence of the East African cichlids and also a few of the West African cichlids. And particularly, I wanted to point out those three clades at the top, because those are clades that inhabit very small lakes. They're monophyletic and exhibit very short branch lengths, which suggests that they may have undergone very rapid sympatric speciation, not unlike that in the rift lake cichlids, but at a much smaller scale. So looking into the future, I see trees not as an endpoint, but as a means by which to look at adaptive evolution and historical processes. So I hope to use this tree to look at adaptive evolution and historical ecological processes in the riverine cichlids, and given their diversity and widespread distribution, try and use this to also understand just tropical evolution in general. Thank you.